Good morning everyone. Welcome to Vidhyalakshmi YouTube channel. So today we start a new topic, class 10 optics, chapter number 2. So first, light. You know very well what is meant by light. Light is a form of energy. It is always travels in straight line and does not need any medium to travel. So these are all the main properties of light. So what is the first property? Light is a form of energy, and second one, light is always travels in straight line, and third one, light does not need any medium to propagate, and fourth one, it is always travel in vacuum. And what is the next thing? What is the speed of light in vacuum? 3 into 10 power 8 meter per second. So this is the next point, next property of light, 3 into 10 power 8 meter per second. And one more thing, the different colors have a different wavelength, and violet is the shortest wavelength and red is the highest wavelength. Okay. So that is why in traffic signals we are using the red colors, no. So the red colors is the highest wavelength, so it will be scattered in long distance. That is why they are using the red color for traffic signals. So see this diagram. So what is the first diagram? This is a reflection, and second diagram refraction, and third one rainbow, and fourth one dispersion of light. I explain one by one. First, reflection. Reflection of light. So what is reflection of light? When the light falls on the any reflecting surface or highly polished surface you have taken as a mirror, when the light falls on the surface, it will be reflect back or it will be sent back into the same medium. So this is called as a reflection of light. All of you understand? So what is reflection of light? When the light falls on the any reflecting surface, it will be reflected back into the same medium, we called as a reflection of light. And next thing, there is a two laws of reflection. There is a two statement or two laws of reflections. So what is the first statement? The angle of incidence is equal to the angle of reflection, and second statement, the incident ray, the reflected ray and normal to the mirror at the point of incidence all lie in the same plane. So this is the second statement. Before we enter this laws of reflections, you know the term what is angle of incidence and what is angle of reflections. So listen, so this is a center line we called as a normal line, and this line we called as a incident ray. So what is incident ray? When the light rays falls on the surface, we called as a incident ray. Okay. So what is angle of incidence? When the angle between the normal line and the incident ray we called as a angle of incidence. And next, what is angle of reflections? When the angle between the reflected ray and normal line we called as a angle of reflection. Angle of incidence is denoted as I and angle of reflections is denoted as R. Now you understand what is angle of incidence and what is angle of reflections. So what is the first statement? The angle of incidence is equal to the angle of reflections. Is it clear, ma? And next thing, the incident ray, reflected ray and normal to the mirror at the point of incidence all lie in the same plane. Okay, so this is the point. Okay, so when the normal line, incident ray, reflected ray all are lying in the same plane. So this is the midpoint of this diagram. So this is the second statement, laws of reflections of light. So what is a normal line means? It is a perpendicular line, otherwise we called as a perpendicular line. So laws of reflection, 2 point is very important. Angle of incidence is equal to angle of reflection, and all the three rays are lying in the same plane. So this is the two statement of laws of reflection. And next we will move to, in images there is a two type of images. What are the two types of images? First one is virtual image and second one is real image and virtual image. So, what is real image and what is virtual image? So, virtual image is like a erect image, erect means we cannot obtain on the screen, erect image we cannot obtain on the screen, but the real image we can obtain on the screen, okay. And it is a inverted image, real image is like a inverted image, but the erect image is the same size of the image, whatever the object is same size means the image is also at the same size. So, this is the difference between the virtual image and erect image, okay. And next, spherical mirror. So, what is the next topic is spherical mirror. You know the plane mirror, in present we are using in our home, we are using the some type of mirrors, no, we called as a plane mirror. So, what is spherical mirror? Spherical mirror is a curved mirror we called as a spherical mirror, and there is a two types of mirror, one is convex mirror, another one is concave mirror. So, what is convex and concave mirror? So many applications we are using the convex and concave mirror, for example, vehicles side mirrors, and dentists we are using this type of mirror, and torches, lamp. So, these are all some uses of convex and concave mirror. So, first what is concave mirror? So, concave mirror is like a spherical mirror, the reflecting surface is curved inwards, we called as a concave mirror. So, what is the other name of concave mirror? We called as a diverging, all the light rays it will be diverging. And next, convex mirror. So, convex mirror is a spherical mirror whose reflecting surface is outwards. Concave means curved inwards, convex means curved outwards. So, the ray of light parallel to the principal axis we called as a convex mirror, and the concave mirror, the ray of light parallel to the principal axis, after reflections it will be meet at a point, diverge. Already I explained, no, concave mirror is a diverging mirror. So, it will be diverge on the principal axis is called as a concave mirror. In convex mirror, the ray of light parallel to the principal axis, after reflections from convex mirror get diverged, and it will be a meet at some behind the mirror, okay. So, clear all of you, this is a two types of mirror, convex and concave mirror. And next thing, some basic terms we are using or we are studying in the spherical mirror. So, what are the basic terms? Center of curvature, radius of curvature, and pole, principal axis and principal focus, and last one is focal length. So, first, what is meant by center of curvature? So, center of curvature is nothing but it is the center of the sphere. It is the center of the sphere, which is the mirror is a part of C, capital C. Center of curvature is denoted as capital C. And next thing, radius of curvature. So, what is the radius of curvature? It is the radius of the sphere. The radius of the sphere of the mirror is called as the radius of curvature, that is Cp. Radius of curvature is denoted as Cp. And next one is pole. So, pole is the center of the sphere, center of the mirror. There is a two types of mirror we are using, no, convex and concave mirror. You have to take any mirror, convex or concave, the center part of the mirror we called as a pole, that is denoted as P. And next one is principal axis. What is principal axis? It is a straight line passing through the center of curvature and the pole. Already you know very well what is center of curvature and the pole. So, the principal axis is like a straight line. So, straight line passing through the center of curvature and the pole we called as the principal axis. And next thing, principal focus. So, what is principal focus? Principal focus is nothing but for example, you have to take concave mirror. The ray of light parallel to the principal axis, after reflections meet at a point on the principal axis. So, that is called as a principal focus F. This is for concave mirror. Suppose convex mirror, we have to take a convex mirror means a ray of light parallel to the principal axis, after reflections it get diverged and appear to come from a point on the principal axis behind the mirror is called as a principal focus. So, this is a two example for convex and concave mirror we taken as a principal focus. And last one is focal length. So, what is focal length? It is the distance between the pole and principal focus. Simply you can remember what is focal length. It is the distance between the pole and the principal axis we called as a focal length. And spherical mirror of radius of curvature is twice the focal length. Okay, r is equal to 2f. So, we need a focal length means r divided by 2. So, we have to find this type of formulas. We can find the focal length for spherical mirror. So, thank you all of you.